Alright, so this is the result. Whitewater, or whitewater particles anyway. So that's something. I mean, it makes sense. You can kind of imagine that the rock is here. Can't be bothered to turn it on right now. And yeah, this isn't even the maximum resolution that we can do for our whitewater. We can kick it up another notch, but I think this is good enough to work with to set up the rest of this. So what we need to do is convert this into a volume. So let's make a density attribute, and then we'll rasterize the density attribute. So if I were to just say density is 1, everybody has a density of 1 now. Volume rasterized attributes, we can just say, hey, how about that density attribute? And we can also say the voxel size should be based off of the whitewaters. It can be based off the whitewaters, or it can be based off of the, you know, our overall control thing. I'm going to make it based off of this just in case it changes somehow in here. So there you go. Come back here. So it's the same situation where it's very faint. There, you can see it there though. Now we can pump that up on the shader when we actually apply a volume shader to this, or really a whitewater shader to it. But I'm just going to say for a moment, volume visualization, and the same business here. This is going to be called, does it have a name? Density. Yeah. I don't know what it's doing. So there you go. And we have, most assuredly, a volume that we can render. Now, there's a few little things here that we might want to do. If you were to set up the whitewater from the whitewater shelf, it does have some good ideas. One of the things that it does is, instead of actually tying the voxel size directly to it here, in order to make it look a little bit more round and bubbly, we make the voxel size a little bit smaller, actually. Because remember, it's rasterizing spheres. Each point represents a sphere. So if each voxel, which is a square, encapsulates one sphere, it just looks like a square. But if we have multiple squares trying to capture one sphere, it starts to look more like a sphere, especially if we make the particle scale bigger. So now we have much smaller voxels trying to capture much bigger particles. So it'll just look slightly more bubbly, which again nudges it slightly in the direction of it looking like an actual bubble-based thing. Set this to accumulated just to make sure that it is getting even more thick in areas where the particles are bunched up. It probably won't look too much different. That's cool. And then this itself, we can do a little bit more, again based on what the shelf tools have suggested. But you can do your anything you want here. I'm just going to say there's two factors that should determine how much density a given particle has: how old it is, and also where it is relative to the surface. We want it to mostly be representational of foam on the surface. So we don't want it to just equal 1 then. We want it to equal, we'll start with the age. So we can say remap the age, which is an attribute we already have. It's in seconds. Remap the age to be something, to be 0 to 1 based on something. So, for example, if we knew that the age ranged from 0 to 1, and we output 0 to 1, well, there you go. It's the same thing. When the particle is just born at 0, it has no density. And by the time it is 1 second old, it has full density. So the only thing we really need to change here is this. I'll say age max. Like so. Where is it? There it is. Age max, this says by the time we get to this age, you are full density. So instead of 1, I'm just going to say something like 1/8 of a second, 0.125. Because again, this is in seconds, not frames. Okay, so now the density ramps in. Probably be hard to see that because it's only 1/8 of a frame, which is like 3 frames. But, you know, it ramps on over 3 frames. So that's something. We can even put this in a ramp if we wanted to. You could say age ramp. and just have that thing that we already have be the input of it. So I'll make this bigger so you can see. So this is remapping the age to 0 to 1, and then the ramp always wants a 0 to 1 input so that it can output something along here. This is the same effect. If you wanted it to like suddenly come in at the end, you could do something like this. I'm just going to keep it like this. I don't really care. The other thing that we wanted to do was do say the density should now times equal itself. Again, we can fit this time the depth, which is another attribute that we have. If the depth is 0, it's right on the surface. So keep that in mind. That's what we want. We want that to be the thing that comes through. So we can say from min depth to max depth. Uh-oh, I see a typo. I hear you screaming at your computer screens over there. And then that will be the min density output to the max. So, you know, I think you get it. It's just another remapping scheme here. And this time we do need to put this into a ramp, because this is going to again return a or actually no, we don't need to do min to max. We could just say 0 to 1 here too. What am I talking about? So this again returns 0 to 1. So let's put this again into a ramp. Well, we'll say depth ramp. Like so. Now this one does matter more. Oh, I got a typo. What did I do wrong? Oh, I'm missing a parenthesis. Too many parentheses? What am I doing wrong? 1 second. Oh, I see it. Sorry about that. Wonderful. So click this, we get a new ramp. So our minimum and maximum should be something below the surface, just something above the surface. And right at this, in the 0 waypoint, which is right in the middle here, we want it to be maximally dense. This one I will make it nice and curvy with like a camel realm spline. Look at that. And you too. So what does this mean? This is saying that the incoming depth value is remapped from negative 0.5 to 0.5, like so. Meaning things that are at 0 will be right in the middle and will come out as 0.5 from this fit. And then that 0.5 looks into this and comes out as 1. So anything lower than negative 0.5 will be 0. Anything higher will be that. So this will kill all of the bubbles that are too far below the surface, and this will kill the spray that leaves the surface, which is what we want. We'll deal with the spray later on, but I don't want that included, in case there is some, in this surface foam. So there you go. Hard to see, but it's there. I'll put a null here, and we have our actual whitewater foam then.